Synthetic division is a shortcut for dividing a polynomial by a binomial of the form x minus a. Our ultimate goal when we use synthetic division is we're generally trying to factor a high degree polynomial in order to find the x-intercepts. That's what we're trying to do. Now, we're not necessarily going to find them here, but that's ultimately what we're working towards. And so that's what we need to keep in mind, because if we can find the x-intercepts, then we can graph something about it, and we have more information to graph a rather complex graph. Now, the key with this question in front of us to remember is that there's no x cubed term. So what that means is that the coefficient in front of the x cubed term is 0. And that's very important to keep in mind, and the most common mistake students make. Now, the factor we're dividing by is x plus 6, which means the root, if we set that equal to 0, is x equals negative 6. So what we can do from that is we can go ahead and take a negative 6 and write it out front. And then we're going to write this box, if you will, one side of the box and then the bottom of the box. And then we're going to write all the coefficients of the high degree polynomial in the first row beside that. So 1, 0 with the x cubed term that's not shown there, a negative 25, 62, and negative 36. So now what we do is we write a plus sign below each of those because we're going to add them to a number in a moment. Now the first number we add is always 0 in the first column. So 1 plus 0 is 1. Now we take the root and we multiply it by 1. That gives us negative 6. We write that in the next column. 0 plus negative 6 is negative 6. Now we multiply that by the root again. That gives me 36. I write that in the next column. Negative 25 plus 36 is 11. Again, we multiply that by the root, negative 66. 62 plus negative 66 gives me negative 4. Multiply that by the root yet again. And the last thing we arrive at is 24, which when I add that together gives me negative 12. Now that number is always the remainder. So that means that the remainder after we did this division is negative 12. The other things are the coefficients starting from right to left with the lowest degree coefficient to the highest degree coefficient. So the lowest degree is just degree 0. And so what we do when we write this out is it's the factor times, well, the negative 4 is degree 0, the 11 is degree 1, and the negative 6 is degree 2, and the 1 is degree 3. So we write this as 1x cubed, or just x cubed, minus 6x squared plus 11x minus 4. That, with the subtraction of 12 at the end, because that's the remainder, is equivalent to that degree 4 polynomial. So that's how it works. It's really that simple. Let's now compare that to doing long division. And let's see if that works out to be the same and what things are common with those two things. So if I go ahead and I do long division, I would go ahead and start with writing an x cubed term. X cubed times x plus 6 gives me x to the 4th plus 6x cubed. If I subtract those one line from the other, I get negative 6x cubed, bring down the negative 25x squared, and I get, now I'd have to multiply by negative 6x squared. So multiply the negative 6x squared by x plus 6, and I get negative 6x cubed minus 36x squared. If I subtract all of that from the line above it, I get positive 11x squared. I keep going, do this process over and over again. I bring down the 62x. Now I have 11x that I'm multiplying by the x plus 6. That's going to give me 11x squared plus 66x. I subtract all of that from the line above it. And what I get is I get negative 4x. Bring down the negative 36. Now I multiply by negative 4 to get the same first coefficient. So that gives me negative 4x. And the negative 4 times 6 gives me negative 24. If I subtract all that from the line above it, I get negative 12 as my remainder. And so you can see that remainder is the same. And that x cubed minus 6x squared plus 11x minus 4 is the same. And so that's the same result that I have below. But let's see if we can notice some other similarities here. Like, why is this a shortcut and how is this helpful? As we already saw with the final answer, the coefficients end up being the same. 1, negative 6, 11, and negative 4. Those are the exact same coefficients. So that's going to give us the same answer. But perhaps more interestingly is if we look at the numbers in the second row of the synthetic division. You see the negative 6 lines up with the second row of the long division. And the 36 lines up with the fourth row of the long division. And the negative 66 lines up with the sixth row of the long division. The 24 lines up with the eighth row of the long division. And so you can see that we're writing a lot less, but we're generating those same numbers in a shortcut fashion. Now let's go ahead and look at another question. 5x cubed minus 7x squared minus x plus 3 divided by x minus 1. Now the factor is x minus 1. And so if we set that factor equal to 0, that tells us what the root is. So x equals 1 is the root. So pause the video here, try this out yourself, and see if you can generate it, and then check your answer later. All right, let's do it. 5, -7, -1, 3. Those are the coefficients. I always start with adding a 0 in the first column. Then I go 1 times 5. 1 times 5 is 5. -7 plus 5 is -2. Multiply the 1 by the -2. That's -2. This is really easy with 1 because it's just the same number. Don't really need to think about the multiplication much. But now -1 plus -2 is -3, which generates a -3 in the next column when multiplying by 1. And I get a remainder of 0. And so what this ultimately becomes is this 5x cubed minus 7x squared minus x plus 3 becomes the x minus 1. And then what I have is that 0 is the remainder. So I have a 5x squared minus 2x minus 3. So there we go. We can write those in. 5x squared minus 2x minus 3. And now at that point, you could try to factor that quadratic or use the quadratic formula to simplify that further to find the zeros to be able to graph that. Again, that's coming up in a later video, but that's the idea behind what we're trying to do, and that's why we're doing it. Here's a question. Can we use synthetic division for a factor like 2x minus 1? The coefficient isn't 1 here. Well, keep in mind that what we've done is we are dividing by the root. What's the root of 2x minus 1? Well, 2x minus 1 is the factor, so if we set that equal to 0, that tells us what the root is. So 2x is equal to 1, which means that x is equal to 1/2. So now what I can do is use that if I was doing division with that. And so setting up synthetic division, it would look with 1/2 as my root, and I would set up everything with that. Let's do this question now with that 2x minus 1. Here we have a degree 4 polynomial divided by 2x minus 1, and so we already know that the root is going to be 1/2. So let's go ahead and set up the synthetic division. So we have 1/2 on the top left, and then our coefficients are 2, 3, -4, 3, and -1. Being careful to make sure that none of them are skipped, and that there's no coefficient of 0. There's nothing here, so we're good. So then we write the plus below that. So 2 plus 0 gives me 2. 1/2 times 2, same process as before, just now with a fraction. So 1/2 times 2 gives me 1. 3 plus 1 gives me 4. 1/2 times 4 gives me 2. -4 plus 2 gives me -2. 1/2 times -2, that gives me -1. 3 plus -1 gives me 2. 1/2 times 2 gives me 1. And so -1 plus 1 gives me 0. And so because that gives me a remainder of 0, what that means is it means that 2x minus 1 is actually a root. It's a factor of that degree 4 polynomial. Now, if we look at the different coefficients, we have to be careful here because you notice those are all multiples of 2. Now, what we actually have divided by here, by taking the 2x minus 1 and rearranging it, setting equal to 0, we've divided by x minus 1/2, not 2x minus 1. 2x minus 1 is actually twice as big as x minus 1/2. So we actually want to be dividing by a number that's twice as big. If we're dividing by a number that's twice as big, that means that all those coefficients are twice as big as they should be. We need to divide those by 2. So we divide all the coefficients by 2, and what we get is we get coefficients of 1, 2, -1, and 1. And so now we can go ahead and write that out. And this becomes 1, 2, -1, 1, like I said. And then if we write that out in terms of the multiplication statement, we can write it as 2x to the 4th plus 3x cubed minus 4x squared plus 3x minus 1 is all equal to 2x minus 1 times, what's the degree of the first one? It's cubed, x squared, then x, then a non-x term. And so we write it out like so. And that is the first step of synthetic division. And then you could apply synthetic division again to that x cubed portion of that to get that factored even further. And so that's the ultimate goal that we're trying to do, because keep in mind, we're trying to find the x-intercepts of these high order or high degree functions. If you want more practice on how to do long division, you can check out my video on the left. For more videos associated with this course in a playlist, you can check out that playlist on the right. Thanks so much for watching. I hope this was helpful, and please consider liking and subscribing.